Alright, so we're moving into the final video for this chapter, chapter 4. We're talking about face perception here. So, as a kind of fun exercise, you may have seen this in the textbook, but do these two faces look different to you? Most people will say yes, and primarily that's because you can kind of see the lines here, right? This is a dated stimulus that was used in a previous project, and so, yeah, this looks different. They didn't have Photoshop back then, but I think. Hold on, I'm about to sneeze, and I sneezed really loud. So, okay, I jinxed myself. I'm not going to sneeze. But when we look at this right here, this doesn't look that different. This looks very different, right? So this looks very, very different. When we're looking at things upside down, we can tell that this picture right here, that there's something different about it, but we don't perceive it to be as unsettling as this right here, where the face and the eyes are all flipped completely upside down. This is another image that I like to show in my sensation and perception class. This is another researcher here. Sometimes it takes people just a second or two to realize which of these is the wrong image, and so you can kind of see now that once it's flipped over that this side is very, very different, right? That his eyes and his face are flipped over, and it becomes very apparent once it is completely or starting to flip over. But from here it doesn't look that different. You can notice it perhaps, but it's very unsettling whenever it's like this. Now, the reason why I'm showing you this is because whenever we are recognizing objects, we typically don't see this big an effect whenever you rotate something. That if you were to just look at, like I don't know, I'm trying to think of something off the top of my head, like a stop sign, for example. If you had a stop sign and then another stop sign, and for one of them the T was upside down, you'd be able to notice that immediately, right? You wouldn't need to flip it over in order to easily tell. But for this, it's kind of difficult. It's whenever the face is right side up that it seems to be that we are processing it differently, that it seems to be standing out. So let's talk about that. So here's an example of what I was talking about how whenever you compare things with letters and words, now which of these is messed up? When they're rotated, you can see this one is the one that's messed up. But generally you can look at this and you can tell very easily, like, okay, that's spelled wrong, or that is different, right? And so this doesn't lead to that same kind of unsettling, weird, like, effect that we get with the others. Here's another example. So which of these is right? Yeah, so here we could probably figure that this is the correct version, because once we flip it over, that card's right side up. So whenever we are looking at inverted faces, they're often difficult to detect changes in them. And that's the reason for that is because faces are not classified like regular objects are. So we're now moving into a territory where Biederman and his recognition by components with geons and all the other stuff is not going to apply to this as much. That we are going to perceive faces differently than we perceive other common objects. One example of this that we know, so I just showed you some behavioral evidence of that, but some neurological evidence of that is prosopagnosia, which is an inability to recognize people's faces. And so you can have damage in part of your brain and be unable to recognize people's faces, but have no difficulty whatsoever in recognizing specific objects. That is called a double dissociation. In other words, you have a part of the brain that is damaged, that disrupts or impairs some behaviors completely independently from all the others that seem to be working and operating, without any difficulty. So people who have prosopagnosia don't have any trouble recognizing common objects, but they do have trouble recognizing people's faces. This is the exact opposite of Kevin, who we saw in chapter 3, the guy with visual agnosia, that he could recognize faces but nothing else. She, in this video, you'll be able to see that she is able to recognize everything except for faces. So we talked about how a specific area of the brain processes faces. So you may remember back in chapters 1 and 2, we talked, or no, I'm sorry, chapter 2, we talked about 2 and 3. We talked about this O'Craven article. And in this specific article, I was talking about how if you were to look at the face that's here instead of the house, and to think about the face, you'd have higher levels of the fusiform face area whenever you're doing that. That's what we're going to be looking at in this video right here, is the fusiform face area. It is an area of the brain that is responsible for detecting and recognizing faces, and this is a cool finding because it is in the neuroscience and neuroimaging literature a very common finding. This is something that people find again and again and again, that whenever people are looking at faces and their brain is being scanned, you're going to have the fusiform face area active. And this is true even whenever people don't consciously perceive there to be a face in front of them. So even if they are looking at something and they don't recognize the face immediately, they can have this part of the brain activated, which suggests that it's some kind of almost like an automatic process. And so the million-dollar question to all of this is whether or not, because whenever people found this, the very quick kind of conclusion that people came up with is like, oh, of course there's a part of the brain in which the face is that it is most sensitive to the face, because that is evolutionary advantageous. That whenever an organism can recognize a face apart from other things, that gives them the ability to perhaps survive or be more competitive than those that can't. And so it stands to reason that that would be true, that you could have a species evolve to have that capacity in their brain because it would give them an advantage. All right. So part of that would be, to recognize specific kinds of enemies, to recognize specific kinds of friendly folks, and parental figures and stuff like that. But there are other pieces of evidence that have come to light. I was not even really recently. This is stuff that all happened kind of around the year 2000. That called into question some of this stuff. That the fusiform face area may not be specific just to faces, but might be something else. And so this is going to conclude kind of the Mount Rushmore of detection, where I said it's either Michael Tarr or one of his students that came out of that lab. And so Isabelle Gauthier she has done a lot of research in this area and came out of Michael Tarr's lab. And so we can put her up as the final face in Mount Rushmore, the Teddy Roosevelt seat. So basically what her research shows is that people that have extensive history and experience in certain stimuli are also going to show activation in that area too. So essentially whenever car experts are looking at cars and discriminating cars from others, that they are going to have increased activation in the fusiform face area than whenever they are looking at anything else. And the same is true for bird experts. Whenever bird experts are looking at birds and trying to discriminate them from other birds, they see fusiform face area activation in that other thing. Now, importantly, in this specific study, they also tested the car experts on pictures of birds, and they tested the bird experts on pictures of cars, and they found that that does not transfer. In other words, that just because you're a car expert, it is active when you look at cars, but not active whenever you look at birds. So here's that data. I'm not going to spend a whole lot of time here because I want to make sure we have enough time to talk about other things, but you can see that again, they're using the subtraction method here. They're looking at scans of faces versus scans of regular objects. And you can kind of see that there's a little bit of activation here, a little bit of activation here. Now they're looking at scans of cars versus scans of objects. So basically finding what is the activation that is unique to whenever you show them cars compared to when you just show them just anything, right? And so for car experts, you can see that that area is active. It's not active whenever the bird experts are looking at pictures of cars. And then finally we have whenever they look at birds versus when they look at objects. And what they find is that for the car experts, that area is not active, but for bird experts, that area is active. So what does that mean? And this just is, this is just another way of looking at the data. It says the exact same thing as what we just saw pretty much. So what does that mean? What does it mean that that whenever you look at something that you're an expert in, that area is active? So one of the things about that study that people were not super convinced by initially is that there's no way to manipulate who was an expert in which field. So, for example, if you are a car expert and you are showing this different kind of pattern of activation in your brain, are you a car expert because you had that kind of proclivity in your brain, or do you have that proclivity in your brain because you are a car expert? It's impossible to say because they couldn't assign an independent variable like that. I guess they could have said, okay, for the next 10 years, we want you to study cars, or for the next 10 years, we want you to study birds, and then come in and do this week-long study. But they don't have time for that. That's not realistic. So the solution that they had to kind of address this criticism is to basically have people train up in a field that was completely new, something that you couldn't have old expertise in any way. And so they did that by training people on something that they call greebles. And if you've taken sensation perception with me, you've come across these greebles before. So these are the greebles. These are completely new stimuli. Some people say that they look like goblins or demons or something like that. And so you can kind of see that it looks like it has, I don't know, to me, it looks like, okay, here's an ear, here's a nose, here's kind of a tongue-looking thing, here's its overall shape. You get the idea. But all of them have that, right? All of them have ears, all of them have noses, all of them have like this tongue or this appendage, all of them have a specific kind of cone shape to them. And so it's in that way kind of like a face as well, because we all have eyes, we all have a nose, we all have a mouth, we all have ears. So whenever people came in for this task, they were asked to memorize specific things. And so the first piece of this, they're going to ask them to look at common objects and see how well they remember them, and they're going to scan their brain while they're doing this. So I will ask you, you can think about this to yourself. If you're going to look at this penguin, I'm going to show you other pictures, and I want you to say if you've seen that picture in this list before or not. All right, here we go. So the answer here should be yes, right? Because you have this visual mask. This is a visual mask. It's called that because essentially this should cancel out any remaining activation in the visual cortex. You should scramble it up so that way you don't have like an after image of a penguin that you can use to compare to the next trial. So trial 1, trial 2, you saw that same penguin, so you would say yes here. Okay, here we go. I'm gonna just go on through the rest. All right, so that should have been pretty easy, right? For most people, that's pretty easy. You'll know if you got one right pretty much immediately because it'll be instantly recognizable. So we're going to do the same thing with faces now. So I'm going to do the exact same task and just test yourself on these faces. All right, so that one, typically people still do pretty well on that, but they say that it's harder than with the cartoons, right? And the reason for that is because in those faces, they all have the same kinds of features, but there are subtle differences, maybe in the complexion, maybe in the hair, but for the most part, all those things were kind of the same. So now we're going to do the same thing with greebles. So these greebles, remember, they all have the same general features. The question then is whether or not you can recognize them compared to others. Here we go. All right, so for me, that one's much more difficult. I was less certain that time around. I feel like I could have gotten all of them, but I felt much less certain than I did with the cartoons or with the faces. And so, if you were a participant doing that particular study, you would be doing a task very similar to that while your brain was getting scanned. After you do that the first day, then you're going to go on to test. You're going to go on to train. You're going to get these greebles. You're going to look at flashcards of them, and you're going to start thinking about what they're supposed to be called. So you're going to have some people who are calling this Doral, some that call this Mora, Priya, Group, Triz, Connie, Julu, Bogo, Narp, and Lodi. I didn't have to say all those names. They were just kind of fun to say. And then you'll see in parentheses here a second name. And so this was just to make sure that, another group got a different listing of names, just to make sure that there was no kind of systematic bias that these names were giving people whenever they were doing it, so they could try it with different names. So basically, people got pretty good at classifying these different kinds of greebles based on these arbitrary names that are assigned to them. So they're studying these greebles, they're learning their names and things like that. And so then they had them test. And so now we're going to do it a little bit harder. So here we go. Last time. All right, so that should have been much harder, right? Because now it's no longer what something is. You have to remember, kind of how to rotate it. It's not something you can just easily, pick up and recognize. You have to do a mental rotation to try to figure out what it is. So anyways, the whole point of this particular experiment was to look at whether or not participants who trained up on greebles would be better. So would their accuracy be better, but also what areas of their brain lit up after training up on this. So before the training occurred, they would scan people and they would find no fusiform face area activation for their greebles. But after they trained up on this, then these areas were active for them. And that's what you can see here in this data. So here, just look at this the side over here on the left. We're looking at novices, so people that had just come in to do this experiment. When they look at faces versus common objects, you can see that yes, these spots with the squares over them, yes, there's lots of activation in the fusiform face area. But whenever they are looking at greebles, there's not that. You don't see any activation there. After only about a week of training, these people that trained up on greebles come in, and we see that yes, they're still active whenever they're looking at faces. But now look at over here. We're starting to see this activation in the fusiform face area for whenever people are looking at greebles versus regular common objects, which means that yes, there is something about experience and something about training in the way that we process or the way that our brain processes the stuff. If it's something that we have lots of training and discriminating it with, or lots of experience comparing and trying to recognize who is who, then we're starting to get that area of the brain activated. So it's almost like this area of the brain is responsible for face expertise, or not face expertise, but stimulus expertise. And what happens is that just for us, just growing up and having to, for all of our lives, recognize people based on their face, even if we don't feel like we're good at it, that is something that we do train up on. And that's probably the reason why the fusiform face area is always active, is because we are all experts in faces. If you are an expert in guitars and recognizing guitars, probably this is kind of like a fusiform guitar area for you, not just a fusiform face area. So really, it should be called something more like a fusiform expertise area for visual recognition. So finally, one last thing that I want to mention is that for face processing, we do this holistically. The book talks about that, but what does that actually mean? Holistic processing just means that whenever we are recognizing faces, when we're normally processing them, we're processing them as a whole. We're processing them all together. We're not just looking at specific features. Some of us can do that. Some of us can pick up on specific features, and that's how we remember them, but that's not natural for us. Naturally, we tend to look at people and look at their whole faces together. And that's what guides face perception. So somebody that has prosopagnosia is going to have problems with that. They might be able to recognize certain features, but they can't put the whole face together. which is how we typically recognize faces, through that kind of processing. All right, so that's all that I wanted to talk about for this specific chapter. If you have any questions, let me know. Otherwise, I will see you in the discussion forums. See you later. Bye.